Hey, welcome to Lesson 2 of Module 6. We are going to continue talking about linear functions. We are going to be interpreting the rate of change and the initial value of the function in whatever context the problem has. I want you to pay particularly close attention to the different vocabulary that's going to be used in these next few lessons. The concepts are very similar to what you've been talking about: slope, y-intercept, equations of lines, but we're going to move into some different contexts. And so as you correct your work, you pay close attention to how well your explanations match the samples in the answer key, so that you can see that you're getting your language correct on these. And I'll try to do that as we do these examples as well, so that you have a good idea of what that will look like. So let's look at example 1. Let's look at the top. It says linear functions are defined by the equation of a line. The graphs and the equations of the lines are important for understanding the relationship between the two variables represented in the following example as x and y. Okay, so let's look at example 1. Okay, so this example 1, is an example from our previous lesson, and it is the MP3 download site that offers a service of downloading songs, and you pay $3 per month for the monthly subscription, and then in addition to that you pay a fee of 25 cents per song. So the linear function that models that relationship is given here, and we talked about that in the last one, and I believe we graphed it. So it's this one right here. I know this is small on the screen, but you can see it on your classwork. So x is representing the number of songs, and y represents the total monthly cost for a given number of songs downloaded. So in your own words, explain the meaning of 0.25 within the context of the problem. And then work on this one too. In your own words, explain the meaning of 3 within the context of the problem. Okay, so go ahead and put some things down for that, and then we'll talk about it. Okay, so for part A, explain the meaning of the 25 hundredths, that number, within the context of the problem. You might have said something to the effect of there's a 25 cents per song fee, okay, which is fine. That is the meaning of that in the context of the problem. But we want to get used to talking about the variables in the context. So a more complete answer would be that the value 0.25 means that, okay, let me catch up, means that for every additional song downloaded, or we could just say for every one song downloaded, okay, the value 0.25 means that for every one song downloaded, the total cost increases by 0.25. So for every one song downloaded, the total cost increases by 0.25. I apologize for the horrible handwriting. It's really hard to write with this pen. Okay, so that's a little different than just saying it's 25 cents per song. Okay, here we've referenced both variables, number of songs downloaded, and for every additional song or every one more song, the total cost, which is y, increases by 0.25. So, so we want to address both variables here. Okay, so part B, in your own words, explain the meaning of 3. And so you might have said something like, the value of 3 represents the initial cost of $3 for downloading 0 songs. Okay, and so that pretty much says it all. Or you could have said something like, there is a fixed cost of $3 just to subscribe to the site, even if you don't download songs. So I won't write that out, but something to that effect. Okay, so so down below on your sheet it says the values represented in the function can be interpreted in the following ways. The 0.25 is the rate of change, and we also have been noticing that that's the slope, and the 3 is the initial value, also known as the y-intercept. But in the context of these functions, we want to describe these numbers as to what they actually mean for the given situation, not just that it's the y-intercept. That doesn't tell me anything about the context of the problem. So, okay, so again, we're being careful about our language, that we give complete explanations here. Okay, so we're going to talk about increasing and decreasing functions. And this is, again, going to be familiar to you, but we want to have precise language when we talk about these things. So the coefficient of x is referred to as the rate of change. So again, this is m, right? We've been using the variable, or the whoops, sorry. Okay, sorry about the technical difficulties there. The coefficient of x is referred to as the rate of change. And so remember when we were talking about y equals mx plus b, m was the coefficient of x, and it's the rate of change. In these problems, we won't always call it m, we won't always call this b, and we won't always call them x and y, but you want to recognize that it's the coefficient of the x term, whatever is going to be on the horizontal axis. Here, we can use x and y, but we might use distance and time or other types of problem contexts. So the coefficient of x is the rate of change. It can be interpreted as the change in the values of y for every 1 unit increase in the values of x. When the rate of change is positive, the linear function is increasing. Okay, so that would be something like that, right? That's a positive slope. That is also, we're going to refer to that as an increasing function. So here's another way to look at that. In other words, increasing indicates that as the x value increases, so as we move in this direction, as the x value increases, so does the y value. So x is increasing and y is increasing at the same time. That's an increasing function. When the rate of change is negative, the linear function is decreasing. So that would be this situation where we have x and y. We have a function that's heading downwards like that. So as x increases, the y's are getting smaller. So notice that. So for this x, got a large y, but as x increases, the y's are decreasing. So we're going to start using that vocabulary a lot more. As x increases, y decreases, or as x increases, y increases. The constant value is referred to as the initial value, or y-intercept, and can be interpreted as the value of y when x is 0. So what they're talking about here is b. So that initial value there, that's the constant in our linear function. The reason we're calling it a constant is because there's no variable with it. This term has a variable in it. It has x. This term has no variable in it. It's just a number, so it's a constant. Over here, the y is also a variable. But when they say the constant value, they're talking about what we've been calling b. Okay, so the constant value is referred to the initial value and is also the value of the function when x is 0. So it's right there. Here's x is 0. There's that constant value. Okay, so we want to be, what we're doing is we're developing a little bit more, I don't know how to say it, but just we're broadening our vocabulary that we use with these linear functions. Okay, so let's look at the next set of exercises. And again, this exercise is similar to problems that we've worked on. So we're watching for precise language as we work on these. Okay, so another site offers MP3 downloads with a different price structure, $2 fixed fee for monthly subscription plus a fee of 40 cents per song. Write a linear function to model the relationship between the number of songs downloaded and the total monthly cost. As before, let X represent the number of songs downloaded and Y represent the total monthly cost in dollars of downloading songs. And then you're asked to determine the cost of downloading 0 songs and 10 songs from this site. Okay, so go ahead and work on that and then come back and we'll discuss it together. All right, so this function is going to look very similar. Our total cost, Y, is going to equal the cost of the songs that we choose to download. So that's going to be 4/10 or 0.4 times the number of songs we download, which is X. And then, there's this plus our $2 fixed cost. So we can write it like that, or we could write it just as 2, because it is a 2. Okay, so there's our function. And so it's similar in structure to the other one. So we're asked to determine the cost of downloading 0 songs and downloading 10 songs. I'm just going to go ahead and write these as ordered pairs because X is the first variable in the ordered pair. So we want X to be 0 and X to be 10. So if you look at this function, when X is 0, this term drops out and Y is just 2. That's our fixed cost. So Y is 2. When X is 10 times 40 cents or 0.4 is going to be $4. And then I have this fixed cost of 2. So my total for 10 songs would be $6. Okay? So that's the cost for downloading 0 songs and the cost for downloading 10 songs. So I've written them as ordered pairs, but maybe I should say 0 songs, $2, 10 songs, $6. Something to that effect. Okay, just to be really clear. Okay, so this graph in number 3, this graph already shows the linear model for the first subscription site for Company 1. That's the one where it was $3 monthly fee and 25 cents per song to download. Graph the equation of the line for the second subscription site, Company 2, by marking the 2 points from your work above, so that's these two, and drawing a line through those 2 points. So let's go ahead and do that. I don't think anybody will have too much trouble doing that. So for 0 songs, we've got $2, and for 10 songs, it's going to be $6 right there. And then we want to draw a line between those 2 points. Okay. All right, so this looks a lot like a system of equations, doesn't it? Okay, so we're going to go to the next page and answer some questions. We'll go back to the graph as we need to. Which line has a steeper slope? Which company's model has the more expensive cost per song? Okay, so the second, let me get my pen back here. The second subscription site has a steeper line. Okay, so the purple one that we graphed is a steeper line. The second subscription site has the steeper line. And it also has the most expensive cost per song, right? Okay, and the second subscription site has more expensive cost per song. Okay. Which function has the greater initial value? So the $3 for company 1 is greater. Company 1 has the greater initial value. Okay, so which subscription site would you choose if you only wanted to download 5 songs per month? And which company would you choose if you wanted to download 10 songs? Explain your reasoning. So we can go back to the graph and look at it. If I want 5 songs per month, I'm going to come up here and notice that it looks like the second company, this purple line, is slightly cheaper for 5 songs. But once I get up to 10 songs, they're more expensive. They're because of the steepness of this line, this one's rising faster. So they're both increasing functions, but this one increased, the purple one for company 2 increases faster. So, and we could say that it looks like right around in here, it's about 6 songs. We definitely want to go with company 1 because of their lesser rate of change. Okay, so something to that extent would explain your reasoning. For these next 3 exercises, 7, 8, and 9, aging autos, you can work on these independently and then come back. So see how you do with you're looking for the rate of change in the initial value and talking about whether it's an increasing or decreasing function. So work on those and then come back and check your work. Number 9 is actually one where you get to write your own. You're given a linear function here, y equals 2.5x plus 10, and you're going to write the context. So you're going to write a story that could be modeled by that linear function with a rate of change of 2.5 and an initial value of 10. So, so look at that one. Oh, I probably gave too much away there. Well, anyway, so work on those on your own and then come back and you can check them against the video. Okay, so number 7, when someone purchases a new car and begins to drive it, the mileage, and that's the number of miles the car has traveled, immediately increases. Let X represent the number of years since the car was purchased, and Y represent the total miles traveled. The linear function that models the relationship between the number of years since purchase and the total miles traveled is Y equals 15,000x. So in this case, we're given the function. We're not just given the pricing structure or whatever. So we're given this function, and we are to do 3 things. So first, identify and interpret the rate of change. So in other words, how is Y changing as X changes? So the rate of change for this one should be the coefficient of the X term, right? So the rate of change is the 15,000. Okay, so that's the identify part. So I identified the rate of change as 15,000, but now I need to interpret the rate of change. So how am I going to say that? It means that every year, so in 1 year, every year the mileage increases, and we can see that increasing by this being a positive slope, increases by 15,000. All right. Because this x, we have to think about what that x variable is. The x is the number of years since the car was purchased. So in 2 years, the car should have 30,000 miles on it, and so on. Okay, so identify and interpret the initial value. Well, the initial value is that constant initial value. And in this case, it's really, we've got a kind of a hiding plus 0. The initial value of this, that isn't right. Let me try to spell it right. Here we go. The initial value is 0. And the interpretation of that would be new cars have a mileage of 0, which isn't always exactly true, but it's very small. Have a mileage of 0. Okay, and part C says, is the mileage increasing or decreasing each year according to this model? Explain your reasoning. The mileage is increasing. It's increasing every year because we're driving the car, right? The mileage is increasing, and we see this, okay, we see this because the rate of change is positive. Positive. Okay. All right, so that's example 7. Let's look at 8. So this is also about aging cars. When someone purchases a new car and begins to drive it, generally speaking, the resale value of the car in dollars goes down each year. Let X represent the number of years since purchase and Y represent the resale value of the car in dollars. The linear function that models the resale value based on the number of years since purchase is Y equals 20,000 minus 1,200X. Identify and interpret the rate of change. Identify and interpret the initial value. And then we're asked, is the resale value increasing or decreasing each year according to the model? Explain. Okay, so let's look at this one. Somebody purchases a new car, starts driving it, and then in a year wants to sell it. And they want to know how much am I going to be able to sell it for? And that's what this function is going to help someone with. Okay, so what is the rate of change? We're going to identify it and then interpret it. Okay, so what do you think? You've worked on this one, hopefully. If you haven't, you should pause it and think about it, because it's not going to help for me just to tell it to you. So the rate of change we saw back, I want to show you that again. The rate of change is the coefficient of x. So it says it right here. The coefficient of x is referred to as the rate of change. Let's go back over here. So in this problem, the coefficient of x is negative 1,200. So the rate of change, we're identifying it, rate of change is negative 1,200. Okay, but let's think about 1,200 what? What would that be? Y is the resale value of the car. So it's going to be in dollars. And then X is the number of years since purchase. Okay, so what this is saying, what this rate of change is saying, is that the resale value of the car is what? Is decreasing by how much? By $1,200 each year. Okay? Decreasing by $1,200 each year. So now let's identify and interpret the initial value. So the initial value is the constant. It's the number that doesn't have a variable attached to it. And that would be this one right here, right? Initial value, I can't seem to write that properly. Initial value is $20,000. And what does the initial value represent? How can we interpret that? And so $20,000 would be the car's value before you drive it off the lot. The car's value at the time of purchase. This is the reason that a lot of people never buy a new car, because the value does decrease quite a bit in the first few years. Okay, so is the resale value increasing or decreasing each year according to the model? I would say, hopefully you did, that the resale value is decreasing. Resale value is decreasing. Explain. How can we explain that? The slope of this line, the rate of change, let's call it rate of change, is negative. Okay, so because the rate of change is negative, the resale value is decreasing. Now, if you got this backwards, if you put $20,000 for the rate of change and negative $1,200 for the initial value, it's because you weren't paying attention to which one was the coefficient of X. We could rewrite this equation, let me get a different color so it stands out. We could rewrite this equation as Y equals negative 1,200 X plus 20,000. Okay, that is exactly the same function written differently. The reason it's written as 20,000 minus 1,200 X is because that's how you think about it. You think about it, for every year I'm going to subtract something off here, not here's my negative part and then I'm going to add it to the initial value of the car. So it's kind of just the way, in this context of an aging car and its value, we think about it differently. So it makes sense to write the function the way they wrote it. So your job is to pay attention to the rate of change being the coefficient of the variable and the initial value is the constant. Okay, so for number 9, again, you're given a linear function and you're asked to write the story, identify the rate of change in the initial value, and explain its meaning with respect to your story. So, of course, there could be lots of different things that this could be. So you can play with that, and please share it with somebody so they can see if it makes sense to them. All right, so what did we learn today? When a linear function is given by the equation of a line in the form y equals mx plus b, the rate of change is m and initial value b. Both are b. Both are easy to identify. Okay, and so we talked about the fact that the rate of change is the slope of the line, and it's the change in the value of y for every 1 unit increase in the value of x. So a positive rate of change indicates that the function is increasing. In other words, as x increases, y increases also. A negative rate of change indicates that a linear function is decreasing. So as x increases, y is decreasing. Given two lines with a positive slope, the function represented by the steeper line has a greater rate of change. And we've seen that again and again. That's nothing new. And the initial value of a function is the value of the y variable when the x value is 0. So some of the new vocabulary, not so new, but maybe slightly different, and we're getting more precise, is this idea of increasing and decreasing functions, and also initial value, and then also locating the rate of change as the coefficient of the variable in the function. Okay, so good luck with the problem set, and also with number 9 in your classwork, writing your own function. And we'll see you back here for lesson 3.